Okay, I'm using this A. Okay, so this A will is going to be stored, right? A is going to be stored now. So this is a variable. We call it as a variable. A is called as a variable, right? So what it's going to store? It's going to store a local variables and address of this particular where the address is going to store. Like it is storing in this particular address, right? So let me take this address as a 2001 or something, etc., etc. Address is there. Suppose example. So that address is going to be placed on the stack, right? And next, data section. So the data section contains the global variable, right? Here stack will contain the local variables, whereas coming to data section, which will holds the global variable data. Okay. Tells you global and data. What do you mean by global and what do you mean by local? A small example, like we can take it as a suppose we can use name called as international or national or state level or national level. If we call state level in the surroundings of like Telangana state level, it will let me take the example Telangana state level. So only in Telangana state level it is going to work. Suppose I am going to use PM is a national level prime minister. Okay, Modi is a prime minister of national of central. We call it as. So he can authorize, he can work on any state in the present in the India, right? So like that. So global is nothing but national level. I mean, it can be used entire section, entire program. Whereas local is nothing but it's going to be used on particular state or particular location only or particular place only, right? Yeah. Next, heap section. So heap section will store data dynamically. Okay, it will allocate some memory to the data. Okay, whatever the data we are providing, like same like stack, it is also going to provide you some memory, but dynamically it will provide. So dynamically is nothing but so it is keep on changing. Okay, it will. I mean, we don't have a fixed constant memory in the heap. Okay, so it will suppose example I have inserted some value like మీకు already you know already C and CPP, right? Already మీ అందరికి C and CPP టచ్ ఉంది కదా. So example here on level, right? Suppose I'm writing int A equals to 10. Suppose example I'm writing A equal to 10, and suppose I'm one more time taking float some B equals to or phi equals to 3.45. యాక్చువల్లీ నేను వేరే ఎగ్జాంపుల్స్ తీసుకోవచ్చు బట్ ఇది ఆల్రెడీ తెలుసు అందరికి తెలుసు కాబట్టి ఇదే ఎగ్జాంపుల్ తీసుకుంటున్నాను నేను రైట్ సో int a equals to 10. So what is the size of integer here? This variable size of integer is 2 bytes, right? The size of integer is 2 bytes, right? The size of float is 4 bytes. Okay, so what happening here means it is based on the size the value is going to be stored. Okay, here 2 bytes means it will store only from 1 to 2 to 6 values only, right? So ఇక్కడ అలాంటి వాల్యూ స్టోర్ చేసుకుంటుంది. సో హీప్ మెమరీ వాట్ ఈస్ గోయింగ్ టు డూ మీన్స్ it will store data dynamically, means whatever the data will come, like what type of data it will come, so based on that it will going to store it will going to allocate the memory to that particular variable, okay, or to the particular data, right? Yeah, so these are heap. So our process will contain these many, a process will contain these many things, okay? It might be a text section or it might be a stack or it might be in a data section or it might be in a heap section, okay? So how many, what is the stack, what are the states present in a stack in a process? Let me see that one. So before this I'll just show you diagram, right? So this is a process. We call it as a life cycle of a process. We can also call it as a life cycle of a process, this one. So here, where is new here? So before ready, we have a new state here. Let me take a new state. Yeah, new. So so this new will I'll just show you once again. Okay, see here. So the new state we are in the new state, ready state, run state. Okay, wait, complete, suspend, and suspended block. These all states we have. Basically, we are going to use new, ready, run. Run is nothing but running, and wait and completed. Only these five states we are going to use regularly, but these two states are some etc. extra. Okay, yeah. So new state will define newly created process. Whatever the newly created process is there is going to be shown you on the new state. Okay, this new state will going to provide you the newly created state. Okay, and it's going to be passed to the ready state, right? So the ready state will going to do whenever after creating a new process. So after creating a new process or after creation of process, move to ready state. That is the process is ready for execution. Okay, so whenever the process is ready, then it is going to be ready for execution. So after this, the ready state is going to be send data to the running state or ready suspended state. Okay, so suppose if if it got any errors or if it got some any unsupported format of process, so it is going to be sent to the ready suspended. Okay, after ready it's sent to the suspend state. So everything is fine, then it is going to send to the running state. Okay, the process is going to be sent to running state, and here it is going to be the running state is going to be used to run the current program or current process. Okay, which is in currently running process by the CPU. Okay, so the CPU will going to execute the required whatever the task we have provided on that particular process, and it is going to execute. If the execution is correct, I mean, if the at the time of execution, if we get any error on that, or if we get any suspension, any blocked content, so that data is going to be terminated, right? If we get any error, like suppose I'm using divide by zero operation in the logical error I'm using, like you all know already know, no? Suppose I'm doing in divide by zero. Divide by zero is nothing but infinity, right? So something by zero is going to be infinity. Suppose I have used that statement in the program. So what it's going to do? It's going to be shown to the terminate error. Okay, termination time side. Or if the error is blocked, I mean, if it is not running. Okay, suppose if it has some problem to get the data from the user resources like input devices కానీ output devices కానీ from where suppose example here నేను ఒక ప్రోగ్రామ్ రాశాను సపోజ్ జావా ప్రోగ్రామ్ రాసాం ఫ్రమ్ వెబ్ పేజ్ నుంచి ఒక ఇమేజ్ రావాలి నాకు స్టేట్మెంట్ లోకి నా ప్రోగ్రామ్ లోకి నా హోమ్ స్క్రీన్ కి ప్రోగ్రామ్ ఒక ఇమేజ్ రావాలి సో ఐఎమ్ నాట్ గెటింగ్ దట్ ఇమేజ్ దట్ ప్రాసెసర్ దట్ యాక్సెస్ ద ఇమేజ్ బట్ ఇట్ ఈస్ ఆన్ ద రన్నింగ్ స్టేట్ ఓకే సో దాని వచ్చేంత వరకు వాట్ ఇట్ గోయింగ్ టు డూ ఇట్ విల్ పుట్ యువర్ ప్రాసెస్ ఇన్ ద వెయిటింగ్ స్టేట్ ఓకే యువర్ ప్రాసెస్ is going to be kept in blocked state or waiting state. We call it as a block or waiting. So there it's going to be placed. The process is going to be placed, and it's going to you ready to accept the next process, right? So once it is completed, then it has again from the blocking state again it's going to send once it get all the resources from the input device or output device or from the network device, whatever it might be. Again, once it get all the status, then it's going to send to the ready state again. From ready state again it's going to send to run state. From there it will execute the complete, it will complete the transaction like complete or terminated, right? Or once it has been completed, it's going to terminate the process again, it is ready to take the new process, right? Okay, so this is the life cycle of a process. Okay, we have new state, ready state, running state, and blocked state or waiting state, and finally terminate state. Okay, yeah. So once suppose example మీకు ఒక చిన్న ఎగ్జాంపుల్ ఇస్తాను. సపోజ్ ఐఎమ్ ఓపెనింగ్ మై క్రోమ్, ఏదో ఒక క్రోమ్ ఓపెన్ చేసి చూద్దాం. సో ఐ జస్ట్ ఓపెన్ దిస్ వన్, నేను ఒక యూట్యూబ్ ఓపెన్ చేశాను, రైట్? ఎగ్జాంపుల్ చెప్తున్నాను ఖాళీ. సో ఐ జస్ట్ ఓపెన్డ్. See, it is in running state. Okay, now here you can see that it is in running state. Why? Because from the through internet problem or whatever it might be, the server problem or internet problem, whatever it might be, it is in running state and it is asking, I mean, to the server to get the data, but it has not received entire data. That's why it is in running state. Okay, if it is keep on running for some time, sometimes when we click continuously here, it will show you not responding. Okay, it will show you some here not responding, right? In some systems, like if you have a less memory or less RAM capacity, when we keep on pressing here something here, whatever it might be, so it will show you here not responding. Okay, so that means it is in a blocked state. Okay, it will be in a, this file is this application is in a blocked state. So once the blocked state will get all the data, it will open. It will again send you to the it will again send you to the same state. I mean, whatever, where like ready state, and from ready to running state, and I run into terminate state. So if it will not get after, if you will not get this one, it is going to suspend the page application, right? So these are things are going to be happened. This is a process actually. Okay. So process is going to be done like this. Yes. So are you able to understand, right? Okay. Attributes and characters of a process. So what type of attributes it will have, and what are the characters of a process will have? Let me see now. So a process has the following attributes. So a process will have process ID, process state, and CPU register, accounting information, input output standard status information, CPU scheduling information, and etc. Okay. So here is the process ID. ID is nothing but it will provide you a unique ID. Like a student is also having a student number, right? So based on the student number, we can identify. Like example, I can take, suppose we have a name called, suppose from our name only. Yeah, example, some Raju, some person Raju is there. So we have a number of Rajus. Like we have two people with the same name called Raju. So to call him identify him, we can use a rule number, right? So rule number is different for both Rajus, right? So that's why it will also provide you a unique identity. So means it is not repeated. Right. Next, process state. So this process ID, once this process ID is created, so in which state it is? It is in new state, or it is in ready state, or it is in running state or blocked state, where it is, the process state will contain that one. Okay. Next, CPU register. So the CPU register will provide you the whatever the memory has been allocated. Okay. The register will allocate the memory to the particular process, and which will going to create some program counter. I mean, it will going to provide you the counter. Like counter is nothing but this memory. Okay, memory is going to be created to that particular process. Next, accounts information. So amount of CPU. So what it going to provide is in the accounts of information, how much time the process has been taken to execute it. Okay, how much time and what type of resources, input of today's resources. Okay, here it will calculate the time, execution time, and how much time it took, and what type of data it has been provided. The throughput of the computer has been used for this process is going to be calculated by the accounts information. Next, input output status information. So input output is nothing but these are the resources, input devices and output devices. So what type of devices are being used to process this process? Like example, let me take in previously. I want to print 10 papers. I want to print this document, this all entire document into, I want to print this one. So I given a print output print. So I have used input keyboard, input mouse, and output printer device, right? So what are the resources used to finish this process? Okay, next, CPU scheduling information. So CPU scheduling information is nothing but it will provide just in the process only I said you, it will provide you in the form of a basic order. Okay, each and every process is going to be executed in some order. Okay, in the starting itself I said you right here, yeah, in a specific order. Okay, there it will see. So in some specific order it's going to execute, right? So what type of order means the CPU scheduling will create the order. Okay, it will provide you a priority. Okay, so this based on this priority, which one has to be executed first is going to be calculated by the help of this priority order. Okay, the CPU will provide the priority order. Suppose example I have given, suppose here in this document only 8 papers are there. See, 8 papers are there here. So when I give print this one, like I'm going to print this one directly, I'm going to click Control P and I will click Enter. Okay, I will click OK. So when I click here, so it will print orderly, right? First from first paper to 8th paper, orderly it will print. It will not print first one or last 8th page, and in middle 5th page it will not print like that. Okay, so why? Because it is also one of the process, and in that process it is maintaining some order. The scheduler, the CPU scheduler will provide you some order to print the pages in the sequential order. Okay, so that is a CPU scheduling. So all of the above attributes of a process is also known as a context of a process. Okay, these all are called as a context of a process. Every process has its own process control block. Okay, PCB. So each and every process will have, we have a concept called process control block also in the next here I have given this one. So each and every process will contain a process control block. So based on this process control block only, we are going to get these all things. Okay, we are going to find these all things. The CPU can understand these all, can create these all things to that particular process. Okay, each process will have a unique PCB. So here also it will provide a unique PCB like process control block. All of the above attributes are parts of the PCB only. Yeah, these all attributes are parts of the CPU only, just as it is, right? So what do you mean by process control block? So a process control block is also called as a task control block. Okay. So whatever the task we are creating, like example, print and pen in the class. So printing is also one of the tasks, right? So it is also called as a task control block. So every process contains the PCB. Just now we have discussed here. Every process will contain the PCB, right? So what type of what type of things it will have means it will have a process state. I mean, state is nothing but it is in ready state or running state or creating state, whatever state. This product, the process control block will contain these many states, these all things. Okay. So whatever I said you, all the above attributes are the part of the PCB, right? So the same states is going to be shown here also. The same attributes, right? Process state. So process state అనేది ఎక్కడ ఉందని చెక్ చేస్తాం. running లో ఉందా process program counter. So program counter, the counter indicates the address of the next instruction to be executed for this process, right? So ఈ ప్రాసెస్ కి నెక్స్ట్ ఏది ఎగ్జిక్యూట్ చేయాలని, లైక్ ఫస్ట్ పేజ్ ఎగ్జిక్యూట్ నెక్స్ట్ పేజ్ ఏది ఎగ్జిక్యూట్ చేయాలని అడ్రస్ క్రియేట్ చేసి పెడుతుంది ప్రోగ్రామ్ కౌంటర్. నెక్స్ట్ CPU register. So the register vary the number and type depending on the computer architecture, right? So the register number, it is going to provide you some memory. Register is nothing but memory. Okay. So memory em chestundi ante it will provide you some memory. So based on the type of the computer architecture, it is going to provide you the memory address. Okay, memory address anadi based on the computer architecture it provides chestundi, right? Like ఇది నేను 64-bit యూజ్ చేస్తున్నాను, 64-bit ప్రాసెస్ క్రియేట్ చేసుకుంటుంది. సపోజ్ 32-bit అనుకోండి, 32-bit ప్రాసెస్. మీకు ఆల్రెడీ చెప్పాను కదా 32-bit ఎక్కడ చెక్ చేయాలనేది. ఇన్ ద లాస్ట్ క్లాస్, ఐ మీన్ ఫస్ట్ క్లాస్ ఐ హావ్ ఎక్స్ప్లెయిన్డ్ యూ వేర్ వీ కెన్ ఫైండ్ దిస్ ఆల్, రైట్? సో example, one second I will show you. So this is my computer, right? So click on properties of this my computer. So you'll get this one. So last time నేను చూపించినప్పుడు 32-bit ఉండే, ఇప్పుడు 64-bit. This is the system type is 64-bit processor. Okay. And I'm using desktop something. Okay, Intel 8 GB RAM. My system, my laptop is 8 GB RAM. Okay, and etc. These all are the right. Okay, and this is a touch screen. See, pen and touch support with the 10 touch points. Okay, so these are touch screen laptop. So it is showing you that way. If you don't have a touch screen, it will show you no touch, like this. It will show you, right? Okay. So based on the processor, it will going to allocate you the memory. Next, CPU scheduling information. So CPU scheduling information in the same, it is going to provide the priorities to the processor and pointers to that scheduling, right? So here it is using a how it going to provide a priority. Normal example. Suppose how it going to provide a priority means it is going to use the queues. Okay. How many people have an idea about queues? Manaku C++ lo untundi data structures using C++. We have a concept called queues. Okay, queues అనే కాన్సెప్ట్ ఉంటుంది. సో క్యూ విల్ గోయింగ్ టు స్టోర్ ద డేటా ఫస్ట్ ఇన్ ఫస్ట్ అవుట్ మేనర్. ఓకే, ఏదైతే ఫస్ట్ ఎంటర్ అవుతుందో, లైక్ ఎగ్జాంపుల్ క్యూ అంటే ఏంటంటే, ఎగ్జాంపుల్ యూ హ్యావ్ ఎ టికెట్ కౌంటర్. మీరు ఏదైనా షాపింగ్ మాల్ ఆర్ ఎనీ సినిమా కౌంటర్, ఎనీ టికెట్ కౌంటర్కి వెళ్ళారనుకోండి, హూ ఎవర్ ఎంటర్స్ ఇన్ టు ద లైన్ ఆర్ టు ద కౌంటర్, హీ విల్ takes the ticket and he will go first out. Okay, whoever enters the last, he will get out from the counter last. Okay, that is the process is going to use. And pointer is going to be, what do you mean by pointer? Pointer is nothing but it is going to store the address of another variable. Okay, the pointer is a special type of variable which will use to store the address of another variable, or which will use to store the address of another content, another memory. Okay, yeah. So priority is going to be assigned based on the pointers to the scheduling queue. Okay, it is based on the queues and pointer values, it is going to be assigned. Next, memory management information. Oh, ikkadiki ayipindi idi, right? Idi next topic idi. Right. So this is the process. This is about the process. Memory management separate kada. Okay. Yeah. Okay. So memory management. So this information may be included such information as the value of base and a limit register, etc. Okay. So memory management information is going to be provided you based on the memory allocated to the particular process, right? Accounting information ఏం చేస్తుంది, ఎంత టైం యూజ్ చేసినాం దీనికి, how much real time it has been used to allocate the to execute. దీనికి standard resources ఏమేమి యూజ్ అయినాయి. So this is a PCB counter. Okay, this is called as a PCB. Okay, PCB is this one, process control block. So this is called as a process control block. So this process control block will contain this pointer process status. Okay, this contain process status and registers, memory limits, list of open files, etc., etc. These are all things it will have, right? So this is about the process. Next, process scheduling. How the process scheduling is going to be happen? Yeah. So the process scheduling, it is the diagram of a process scheduling. So what it means, the scheduling mechanism is a part of the process manager that handles the removal of the running process on the basis of the particular strategy. Okay. So scheduling queues, when the process enters into the system, they are put into the job queue, right? So ఇందాకనే మనం అన్నాగా CPU షెడ్యూలింగ్ ఎలా చేసుకుంటుంది అన్నది. సో ప్రయారిటీస్ ఆఫ్ బేస్డ్ ఆన్ ద క్యూస్, రైట్? సో ఇక్కడ కూడా అదే ఉంటుంది. సేమ్ ప్రాసెస్ షెడ్యూలింగ్ ఇస్ ఆల్సో వన్ ఆఫ్ ద సేమ్ థింగ్. సో బేస్డ్ ఆన్ ద మేనేజర్, హూ ఆర్ ద మేనేజర్, ప్రాసెస్ మేనేజర్, లైక్ ఇక్కడ కూడా మనకు ఈచ్ అండ్ ఎవ్రీథింగ్ ఈస్ గోయింగ్ టు బి మేనేజ్డ్ బై ద హెల్ప్ ఆఫ్ మేనేజర్ ఆర్ అడ్మినిస్ట్రేటర్ అన్నట్టుగానే ఉంటుంది సిస్టమ్ లో కూడా. సో దట్ ఈస్ గోయింగ్ టు బి అలొకేట్ when the process is going to be executed and what is the ID, unique ID for the particular process. Okay. So once it enters into the ready queue, that either the process untundo, once it enters into the ready queue, this is a process from entering into the ready queue. So it will directly send to the CPU. Okay, the process ki CPU send చేస్తుంది. So once the CPU takes the requirement of the process, so it will execute. Okay, it will execute and it will terminate. So if it need any allocation time, I need any resources like input output resources or time scheduling from memory, from network, it going to get some data or wherever it might be, like a child execution, fork, these all things execution. So it is going to send to that one. If it requires any input device, suppose నేను దీని ఇప్పుడు ఈ డాక్యుమెంట్ నేను ప్రింట్ ఇచ్చాను. Okay, I given a print, but what happens, it is not going to print. Why? Because it asking you to provide the resource. I don't have a printer here, so it asking you to provide the resource here. Okay, దీని ప్రింట్ కి కొట్టాను నేను. ప్రింట్ ఇచ్చినప్పుడు ఏమవుతుంది, ఇట్ ఆస్కింగ్ యూ ప్రొవైడ్ ద రిసోర్స్. సో until and unless I get the resource, the process, the CPU is sended this whatever the task I have given to the computer, it has been kept into the input or output device. Okay, ఇది ఎక్కడ పెట్టింది ఇప్పుడు నేను ప్రాసెస్ ని, ఇందులో ఈ డివైస్ లో పెట్టేసి ఈ ప్రాసెస్ లో పెట్టింది. అండ్ ఇక్కడ ఏం చేస్తుంది, ఇది ప్రింట్ ఇచ్చాను కదా, అదొక ఆడ పెట్టేస్తుంది, రైట్? మళ్ళీ అగైన్ I given one more work. So again that also kept in this only. Okay, if it is executed, it will execute directly. If it is not executing, it will put in the queue. Okay, input queue or output queue. Okay, or if it needs some data to get from any network or somewhere else, it's going to be kept in the interruptions or waiting for an interruption or something, etc. Again, once the resource once that task got the resources, then it again is sent to the ready queue, and it will send to the CPU and it's going to be executed, right? So this is a process scheduling, right? Are you able to understand? Right. Next, threads. So a thread is a path of execution within a process, or a thread is called as every process will contain every process. ఇక్కడ అన్న మన ప్రాసెస్ అన్నాం కదా. సో ఈచ్ అండ్ ఎవ్రీ ప్రాసెస్ లో మనం ఇక్కడ ఒక టాస్క్ ఇస్తున్నాం. ఆ టాస్క్ లో ఏ సీక్వెన్స్ ఆఫ్ ఎగ్జిక్యూషన్ ఆఫ్ ఎ టాస్క్ ఇస్ గోయింగ్ టు బి, వి హావ్ ఎన్ నెంబర్ ఆఫ్ టాస్క్ ఇన్ ఏ ప్రాసెస్ or n number of instructions in a process. So each and every instruction is called as a thread. Okay, each and every instruction in a process is called as a thread, right? So a thread is a path of execution within a process. A process can contain multiple threads. Okay, a process can contain multiple threads. The primary difference is that threads within the same process run in a shared memory space, while processes running in separate memory spaces. Okay, yeah. So thread and process both are same actually. Okay, when we are executing thread, process means thread is also executing, but only difference ఏంది అంటే when we are running the same process, okay, whatever the threads present in the same process, that threads are going to be executed or shared in the memory space, same memory space only. In the same memory space is going to be executed. While the processes, whatever the different processes ఏవైతే ఉన్నాయో అవన్నీ separate memories లో execute అవుతాయి, right? So threads are going to be defined in two types. Okay, what are they? User level threads and kernel level threads. Okay, user level threads and kernel level threads, we have two types, right? What do you mean by kernel? In the last class I have explained you, kernel is nothing but an operating system, heart of the operating system, right? It going to act as an interface between a user and it going to act as interface between a computer and a operating system. Okay, hardware and an operating system, right? Right. So here user level threads are there and kernel level threads are there. So what they are going to do means I have given a difference here. So user level threads are implemented by users. Okay, user level threads are implemented by users. So we are the users, we are implemented these threads. And kernel level threads are implemented by the operating system. Okay, so whatever the threads we have given here, like example, I just give you a small example. So ikkada తీసుకుందాం. So these are the threads. Suppose, yeah, this is one of the process. In this process, I have different types of threads. These all are called threads. Okay. Sorry. So these are called as a threads. Okay. These are T1, T2, T3, T4. Let me take an example. Okay. And ikkada threads ela untayi ante it will look like this only. Okay. It will look like this only. Okay. Threads are like this only.
సార్ మీరు ఎక్కడ ఎంటర్ చేస్తున్నారో మాకు కనిపించట్లేదు సార్. ఇది డిఫరెన్స్ మాత్రమే కనిపిస్తుంది.
డిఫరెన్స్ కనబడుతుంది. ఇది కనబడట్లేదా మీకు?
నో సార్.
యా, ఈ పెయింట్ ఓపెన్ చేశాను, కనబడట్లేదా?
నో
ఓకే
సార్.
ఓకే, 1 second. I just open 1 second. Yeah, okay. Are you able to see this one?
Yeah, sir.
Yeah, okay, fine. Yeah. Okay. So, example, this is a process. Okay, this entire is a process. So in this between, we have a threads, different types of threads. Okay. So these threads are going to be look you like this. Okay. Threads అనేది ఇలా కనబడుతాయి మనకు. నార్మల్ అయితే ఇలాగే ఉంటాయి, ఒక different ways లో ఉంటాయి. Yeah. So these are the threads T1, T2, T3, T4. Okay. So, okay, whatever. So we have different types of threads here. So these threads are going to be, these threads are created by whom? Through the user. Okay. So user level threads are going to be created by user. Okay. User has created this one. Example. Let me take this example. Okay. So what happens? These user level threads are going to be executed by the kernel. Okay. We have a kernel here. Let me take one kernel. Either good example, this kernel diagram. So this is a kernel. So this kernel will execute these threads. Right? Yeah. So the kernel will going to be execute these threads based on the operating system. Okay. 1 second. I will share you one more. That only difference one. Okay. Are you able to see the difference? Word document open చేశాను ఇప్పుడు కనబడుతుంది కదా?
Yes, sir.
Right. Okay. So OS does not recognize user level threads. Okay. OS does not recognize user level threads, whereas kernel threads are recognized by operating system. Okay. So మనకి ఏంటంటే kernel దగ్గరికి వెళ్ళిన తర్వాత whatever the threads has been given by the user, once it going to reach the kernel level only, then only the OS can recognize whatever the threads are there, whatever the threads has been in the process. Okay. Implementation of user threads is easy. Okay. Implementation of kernel level threads is complicated. Why? Because it is based on the machine understandable language. Okay. We can't understand what is the we can't write kernel level threads, right? So context switch time is less here. So here context switch time is more. Okay. I mean we can create this threads easily. Okay. Here it will take some time to create this one. So context switching requires no hardware support. Here it requires no hardware support. But here to create this to run these threads, so kernel level, the hardware support is required. So if no user level threads perform blocking, if one user level thread perform blocking operation, then entire process will be blocked. Okay. If one kernel thread perform blocking operation, then another thread can continue execution. Right. So this is the main difference. So when user has created some n number of threads. Okay. So if any thread has got some blocking state, in the blocking state or any error state, so entire program is going to be blocked. Like example, one of C program rasam example. So if you are using any error on that particular program, on the C program, So what happens? It will not execute. Why? Because we have some error on that, right? Once the error is clear, then only the entire program is going to be executed. But in the kernel level, where compared to the user level, the kernel level will execute if any one thread has been in a blocking state also. Is in a blocking state or terminated state, whatever it might be. If it is in blocking state also, it will execute the another threads without any disturbance. Yeah, user level threads are designed as dependent threads. Okay, user level and dependent threads can depend outundi. Whereas kernel level threads are designed as independent threads. Okay, so that each and every threads present in a particular program, how many each and every line is independent to each other. Whereas coming to here, all the threads are different. Okay, example Java thread or P6 or POSIX threads. Okay, these are the examples we can use in the Java. Also, we are using Java threads. Okay, yeah. ఇక్కడ ఏంటంటే Windows, Solaris, and any OS operating name we can use here. Mac, Macintosh, like you can use like this. Okay, these are the kernel and user level threads. Yeah. So next, inter-process communication. More okay. Okay, 2 pages అయితే first second note అయిపోతుంది. Yeah. So next, inter-process communication. So inter-process communication is nothing but so the IPC means we can also call it as IPC. IPC means the process to communicate with each other while they are in running. Okay. So ఇక్కడ ఏంటంటే inter-process. So inter-process is nothing but so each and every one, whatever the processes are there, which are going to be synchronized each other. Okay, each and every process is going to synchronize with each other. Okay, and sharing their address space or sharing their memory space, whatever it might be. So based on that, it's going to be synchronized by each other. Okay, that we only communicate of execution process, right? So IPC is best provided by message passing system. Okay, based on the message passing system, the IPC ఇక్కడ మధ్యలో కొంచెం మ్యాటర్ పోయింది. Okay, so based on the message passing system, the IPC is going to be provided, like sending and sharing is going to be done based on the message passing system only. So we have two types of systems here, sending system and receiver system. So the sending system will contain the destination name, so where to send the data, and the name of the destination and what type of message it will have. Okay, and the receiver will contain two parameters, which is source name and the message, whatever the message is there. Okay, so here the sending message is going to be sent to the particular destination name, to the particular destination place, and the receiver will accept that particular source, whatever the source, where it should be saved, where it should be sent. Okay, so designing a message system. How to design a message system means we have different types: synchronization, format of the message, and addressing and queuing discipline. Okay, so sending synchronization. Just now we discussed here, synchronization means, so synchronization is nothing but the communication of a message between two processes implies some level of synchronization between two processes. Okay, the communication of a message between two processes, right? The communication of message between two processes are going to be done by the help of synchronization. So which will implies some level of synchronization between the two processes. So the sender and receiver will communicate with each other, and which is going to be in a synchronization process. So the sender will send the sender and receiver can be block or non-blocking state. So what we see, let me see that one. We have different types here. So the sender is in a blocking state. He is in blocking send or blocking receiver, non-blocking send and blocking receiver, non-blocking send, non-blocking receiver. So what it means the sender. One second, I have internet problem. Oh, right. So what happening here means the sender and receiver both can be in a blocking state or both can be in a non-blocking state. Okay, so we have different types of scenarios here. So the sender can block whatever the blocking state is there. The sender can block the data, and receiver is also in the blocking of the data, blocking on the block of the data. Whereas coming to next scenario, the non-blocking send, the sender is in non-blocking state and the receiver is in blocking state. Okay, the sender is in non-blocking state and the receiver is in blocking state. Next, the sender is in non-blocking state and the receiver is in non-blocking state. Both are in non-blocking state. right? So what happens here? The data is going to be received, or the data is going to be sent from the sender or the receiver. Okay, the sender and receiver, who can block the data and who can unblock the data. Okay, unblock the state. All right. In any scenario, it can be work. Next, addressing. So addressing can be done in the direct communication or in indirect communication process, right? From process to process, directly it can send the data, or from process to process, indirectly it can send the data. So direct communication is going to be done. Link in associated directed between two processes. Okay, it will provide a link. This is called as a link. Okay, this is a link. It will provide a link between directly. It will provide a link from process 1 to process 2. Okay, whereas indirect communication, it will provide a mailbox in between the process 1 and process 2. It will provide a mailbox. So each and every process is going to be communicated with process 2 based on the mailbox. Okay, the process is going to be sent to the mailbox B. From the mailbox, it's going to send to second process. Okay, so a mailbox is placed in between the two processes. Is called as a indirect. Whereas directly link provided, a link is going to be a direct link has been given to the process, is called as a direct link, direct communication. Next, queuing discipline. Queuing discipline is nothing but each and every message is placed in a queue, and based on the priority, the message is going to be executed between two processes. Okay, so each and every process is going to be placed in a queue. A queue lo place chesi, and based on the priority, the message is going to be executed between the process. Okay, and one more state ikkada manam format of the message format emuntadante sender and receiver. Okay, the message formats will be in the form of a sending and receiver formats, right? Yeah. Okay, in the process we have two problems. One is the dining philosopher's problem, and another one is the readers and writers problem. Okay, so the dining philosopher's problem is one of the problem where suppose example, this is a dining philosopher problem example. So we have a dining table here. Okay, I will read this one. The dining philosopher problem states that K philosophers seated around the circular table with one chopsticks between each pair of the philosophers. Okay, suppose example, it is a one dining table. In dining table, we have a food here. Okay, and he is the process 1, philosopher 1, philosopher 2, philosopher 3, philosopher 4, philosopher 5. So 5 philosophers are sitting beside one by one. Okay, beside to each other, and they have a chopsticks like forks. Chopstick is nothing but fork. Okay, so these forks are placed here. 5 forks are there, right? Suppose example, this food is noodles or whatever it might be. Okay, some food is placed here. So the condition is that each and every, okay, a philosopher may eat if he can pick up the 2 chopsticks adjacent to him. Okay, the condition is that suppose this philosopher P1 is hungry, he want to eat, so he has a condition to pick up his right chopstick and right fork and left fork. Both he has to pick up. Okay, so he has to pick up both. We have to use both his right hand fork and his left hand fork adjacent to him. Okay, so one chopstick may be picked up, and any one of the of its adjacent follower, but not both. Okay, actually the conditions ఏంటి అంటే ఇక్కడ ఇతను he can pick right side fork and left side fork. ఇతను కూడా right side fork pick చేసుకోవాలి, left side fork pick చేసుకోవాలి. And P3 also has to pick the both forks, and P3 also pick both forks. Okay, he must use the 2 forks at a time. Every philosopher should use 2 forks at a time. So here what happens? So when philosopher 1 will use this one, so the philosopher 2, we don't have this fork. Okay, right side fork anadi ledhu philosopher 2. Okay, he can use only left side fork. So he is not able to eat the food. Now philosopher 3, so he has 2 forks. Okay, he can take the 2 forks, and P4, I mean philosopher 4 can't take the right side fork, right? Whereas coming to philosopher 5, already this fork has been taken by P1. So simultaneously only P1 and P3 are using these forks. Okay, but P2, P4 and P5 are not using the forks. They don't have the forks to eat, right? So this is the condition. So to overcome this condition, we have a semaphores. Okay, to overcome this condition, we have a semaphores. Open this one. So example. Okay, are you able to see this one? నేను వెబ్ పేజ్ ఓపెన్ చేశాను, బ్రౌజర్ ఓపెన్ చేశాను. ఓకే, సో semaphores. Based on the semaphores, we have a solution to create this one. So how it going to do means it has created some program like this, like when the philosopher want to eat, so he will pick the chopstick of 1 and he will pick the chopstick of 1 plus 1 divided by mod 5. Out of 5, how many he has, he will pick that one. Okay, like that it has been created. So in program అనేది కొంచెం మనం ఈ పాయింట్స్ రాయాల్సి వస్తుంది. Okay, so whenever whoever the philosopher is there, a philosopher can eat the process. Okay, by the help of this semaphores, we can solve this problem, right? So sometimes what happens means ఇది ఏమవుతుందంటే, but while using the semaphores, it's going to be created on a deadlock state. It's going to be going to a deadlock state. Okay, the semaphore the problem is going to be deadlock state, right? ఇక్కడ నేను ఇది ఇచ్చాను, ఇది చదువుకుంటే మీకు అర్థమవుతుంది, బట్ కోడ్ అనేది చాలా పెద్దగా ఉంటుంది, జస్ట్ మీరు ఇంత పెద్దగా రాయాల్సిన అవసరం లేదు. సో దిస్ ఆల్ కోడ్ యూ హ్యావ్ ట్రైడ్ టు ఓవర్కమ్ దిస్ ప్రాబ్లం. ఇదంతా కోడ్ రాయాల్సి వస్తుంది. ఓకే, సో థియరీ రాసేసి మనం
సబ్జెక్ట్ లో కోడింగ్ కూడా ఉంటుందా సార్?
కోడింగ్ ఏమి ఉండదు యాక్చువల్ అయితే, మీకు కోడింగ్ ఏమి ఉండదు, జస్ట్ థియరీ రాయాలి. బట్ ఇక్కడ ఏంటంటే సమ్ ప్రాబ్లమ్స్ విల్ హ్యావ్ సమ్ కోడ్. ఓకే, semaphore అనేది మనము బేస్డ్ ఆన్ ద కోడ్ ఓన్లీ వీ కెన్ ఎగ్జిక్యూట్ దట్ వన్, ది semaphore అనేది. ఓకే, అందుకే మనం ఏంటంటే జస్ట్ థియరీ రాస్తాము. జస్ట్ కాన్సెప్ట్ ఏంటంటే ఇలా ఈ యొక్క ప్రాసెస్ ని చూస్తారు, బేస్డ్ ఆన్ దిస్ ప్రాసెస్ semaphore విల్ ఎగ్జిక్యూట్ అని చెప్తాం అంతే. ఇదంతా కోడ్ రాయాల్సిన అవసరం లేదు, బట్ చూసుకుంటే బెటర్. అవసరం లేదు, మీరు రాయాల్సిన అవసరం ఏం లేదు. యా, ఓకే. Yeah, in next one, reading and writing also one of the same program we have. So next, readers writers problem. Next one. So the readers writers problem is also one of the problem where at a time where the readers are there. So same time the reading and writing process is going to be done. Okay. So synchronizing by the help of synchronization, the reading and writing, various reading process and various writing processes are going to be executed simultaneously. So here it has some inconsistency and the data anedi correct ga ravatledu. So here, so to overcome that one, we have a reading and writing problem. So this is the table 1 example. So in the case 1, when we are using writing and writing both process in the same state, writing state, so it is not allowed by the computer. So in the case 2, so for example, when it is in reading state, when it is in writing state, it is also not allowed. Okay, it should be any one state only one process only is going to be worked. Okay, ఒకటే process అనేది reading ఈ states కి allow అవుతుంది. Only for the combination of synchronization process లో ఎప్పుడు అవుతుందంటే, when both are in reading state, then only it is allowed. Okay, so synchronization process lo run avali, I mean both processes are synchronizing each other. When both are in reading state only, then only the CPU is going to allow you. But whenever it is in reading and writing state or writing state or writing reading state, the CPU will not allow you to do that problem. Okay, so for that we also have the scenario with the help of semaphore we can create that we can overcome this problem. So semaphore is going to be executed. మనకి ఇందాక చెప్పినాం కదా semaphore అంటే ఏంటని. What do you mean by semaphore means it is the one of the variable. Okay, we are going to create with the help of s తో denote చేస్తారు variable. So what that variable will contain means it has two functions, wait function and signal function. Okay, so the wait function and signal function, based on these two functions, the execution of this particular process is going to be executed. So whenever the process 1 is coming into the wait state, so the process 2 is going to be executed. Okay, so it will increment to the semaphore place. Okay, while semaphore is less than or equal to 0, it will decrement. If it is, I mean here it is going to decrement the process waiting state lo, and signal eppudithe signal arise avangane the semaphore is going to be increased, the signal instance is going to be increased and that process is going to be executed. So based on this ఇది ఒక్కటి కొంచెం బట్టి కొట్టాల్సి వస్తుంది. అంటే ఏం లేదు, వెయిట్ అండ్ సిగ్నల్ అనేది 2 states కంపల్సరీ ఉంటాయి semaphore లో. Based on these 2 states, the data is going to be executed. So in the wait state, it is in the waiting is nothing but as waiting state లో ఉన్నప్పుడు ఏమవుతుంది, the semaphore అనేది తగ్గిపోవాలి. I mean the signal అనేది తగ్గిపోయి it has to enter into the process, next process. The next process has to come. So once the signal occurred, I mean once the signal enters into the next process, then it will increment the, after executing that particular process, it will increment to the next process. Okay, that thing is going to be happen. So for reading and writing also, we have different types of codes here. But మనకి అంత కోడ్ అవసరం లేదు బికాస్ థియరీ సబ్జెక్ట్ ఇది, మనకి అంత అవసరం లేదు. జస్ట్ వాట్ ఈస్ వాట్ అని రాస్తే సరిపోతుంది అంతే. సో దిస్ ఇస్ అబౌట్ రీడింగ్ అండ్ రైటింగ్ ప్రాసెస్. Okay, yeah, with this our second unit also completed, our third unit. But actually మనకి సబ్జెక్ట్ అనేది చాలా లెంతీగా ఉంది, బట్ 6 classes లో అయిపోతుంది అయితే నమ్మకం లేదు నాకు. It will take more 1 week for us. Right, let we continue to the next unit or let we take it in next class?
Time is there, continue it, sir.
Okay, everyone అంటే okay, మనం just ఒక 2 concepts
5 minutes, sir.
Okay, fine. Okay, for 5 minutes, right? Okay, let we finish this one within 5 minutes. Yeah. So our third unit is memory management. So memory management, already you know what do you mean by memory? Memory ante manaki it is a storage part. Okay, memory is nothing but storage content. So the management will help you how to allocate the memory from the hardware in the hardware, and how to use that memory and how to process the memory. Okay, at what process, what type of memory we have to allocate, how much memory we have to allocate, another memory management will show you, right? So a memory management unit is a computer hardware component that handles all memory and caching operations associated with that processor. Okay, so it will, a memory unit we have, a memory management unit will have, like CPU lo manaku untundi memory management unit, block diagram of computer. In the last class I showed you block diagram of computer lo memory management unit untundi. So what it going to do, it will allocate or handles all the memory concepts, all the memory things, memory related things. Okay, and what type of processor, a processor ki elanti data vachina sare, where it has to be placed, like in main memory or physical memory or secondary memory. Okay, like that it will check them, right? So we have different types of memories, and we have a concept called virtual memory. So virtual memory is nothing but a memory which is invisible. Okay, virtual memory అనేది ఒక memory which is invisible to the, which is an instance. Okay, instance లాగా కనబడుతుంది మనకి, but it is not going to be we can't see, like మనకి ఇప్పుడు మొబైల్, suppose example, in my computer this is the memory, right? This is a secondary memory. I am using secondary memory, like this is 100 GB and this is 150 GB example. So 250 GB I am using here, right? So it is a visible memory. This is called as a physical memory. Okay, this is a physical memory. But here, but virtual memory, it is an invisible memory, like virtually we are using that one. Okay, so each and every process is going to be assigned, is going to be created in the present in the virtual memory. So virtual memory sometimes which appears to be present, but actually it is not present. Okay, it just gives the illusion, right? Virtual memory is dynamic, not constant, dynamic or not constant, where as main memory is a constant. Okay, so each and every processor, actually ఇక్కడ మెయిన్ కాన్సెప్ట్ ఏంటి అంటే, వర్చువల్ మెమరీలో ఫస్ట్ ఆఫ్ ఆల్ మనం ఎలాంటి ఇన్పుట్ ఇచ్చినా సరే, డేటా ఇప్పుడు మనం ఈ ప్రోగ్రామ్ రాస్తున్నాం, దీన్ని సేవ్ చేయట్లేదు నేను, సో ఇట్ విల్ క్రియేట్ ఏ వర్చువల్ మెమరీ. ఓకే, అండ్ ఇక్కడ నాకు ఈ సైజ్ ఆఫ్ దిస్ ఈ పేజ్ ఉంది, అలాగే ఈ పేజ్ అంత సైజ్ ఆఫ్ దిస్ పేజెస్ సపోజ్ ఎగ్జాంపుల్ ఒక 1 MB ఉంది అనుకుందాం. సపోజ్ మనం ఒక ఫోటో తీసినప్పుడు 1 MB ఉంది అనుకుందాం. బట్ అంటిల్ అండ్ అన్లెస్ వి సేవ్ ఇట్ ఇన్ టు ద ఫిజికల్ మెమరీ, లైక్ మెయిన్ మెమరీ ఆర్ సెకండరీ మెమరీ, దీని సైజ్ ఎంతో చూపిస్తుంది అంటే మనకు 3 GB 3 MB 4 MB చూపిస్తుంది. ఓకే, సో ఇట్ విల్ షో యూ మోర్ మెమరీ. ఓకే, వర్చువల్ మెమరీ అనేది ఏంటంటే it will allocate more space to the particular process, but really it will not have that much of space. Okay, suppose example, నాకు ఇక్కడ 4 GB ఉంది అనుకోండి. సపోజ్ ఎగ్జాంపుల్ we have a 4 GB of RAM, suppose 4 GB ఉంది, 4 GB of data ఉంది, but until and unless I save this data into the memory, into the secondary memory or physical memory, it will show you up to 16 GB. ఓకే, అప్ టు 16 GB వరకు చూపిస్తుంది ఇక్కడ వర్చువల్ మెమరీలో. సో మెయిన్ మెమరీలో స్టోర్ చేస్తే మనకు అదేదో మెయిన్ మెమరీ స్టోర్ చేస్తే ఇట్ విల్ బి 4 GB ఓన్లీ. ఓకే, బట్ అదే మనం వర్చువల్ మెమరీలో స్టోర్ చేస్తే ఇట్ విల్ షో యూ 16 GB. ఓకే, లైక్ దిస్ ఇట్ విల్ షో యూ. సో ఇట్ విల్ allocate more memory. ఓకే, బట్ ఇట్ ఈస్ నాట్ ఏ ఫిజికల్, ఐ మీన్ మోర్ మెమరీని చూపిస్తుంది, బట్ ఇట్ ఈస్ నాట్ ఫిజికల్లీ, ఇట్ ఈస్ నాట్ లోడింగ్ ఎనీ డేటా ఇన్ టు ద కంప్యూటర్, రైట్? Yeah, more programs running currently using this memory only. Okay, this virtual memory ద్వారానే చాలా ప్రోగ్రామ్ అంటే all programs, maximum programs are going to be run by the help of this virtual memory. Until and unless నేను చెప్పాను ఇందాక, until and unless we save it into the permanent memory, it will show it in the virtual memory only. So less input output needed to load the or swap process. So here, to swap the process from one place to another place, or to exchange the data from one place to another place, it requires less number of resources. Okay, so VM also, virtual memory also called as a logical memory. Okay, one of the logical memory, we also call them as the logical memory. So this is a virtual memory. So the CPU, so whatever the thing it is storing, so based on the pages it is going to store the process. Okay, each and every process is going to be stored in the form of a page. Okay, so based on the page, the data is going to be stored in the virtual memory. So this virtual memory is going to send to memory map. It will contain one memory mapping content. So this memory mapping will have the address of each and every page. Okay, this memory map will contain address of each and every memory page, and it is also having the address of each and every address of this physical memory. Okay, it is also having the address of memory pages, virtual memory, and it is also having the address of physical memory. So whatever the page has been given to the virtual main memory map, it is going to be mapped to this particular physical memory area. Okay, suppose example, page 1 and page 0 అనేది page ఇక్కడ memory 1 కి వెళ్ళాలి. So it will send to that particular memory. So this address and this are both address are maintained by memory map. And once the, or suppose this is a physical memory. Suppose I want to store data, like example in disk, I am using separate pen drive. Example is pen drive anukundam. So I'm using a pen drive here. So I'm using, with the help of pen drive, I'm playing this. I have opened this document. Example. So by the help of pen drive, this CPU is running data through pen drive. Okay, not through physical memory. Okay, అర్థమవుతుంది కదా. So when I'm opening any data, any content from pen drive or any CD drive or any memory disk, whatever it might be. So with that, from that it is opening. Okay, this content has been, this page has been opened with the help of this pen drive. So it is showing you from the pen drive. So it has been placed some memory map, and with the help of that memory map, it's sent to the disk or vice versa. Okay, ఇక్కడ డిస్క్ నుంచి మనకి మానిటర్ మీద ఈ పేజ్ కనబడుతుంది, అంటే డిస్క్ అంటే ఇది పెన్ డ్రైవ్ నుంచి. సపోజ్ ఐ వాంట్ టు పర్మనెంట్లీ సేవ్ దిస్ డేటా, ఈ ఫైల్ ని పర్మనెంట్ సేవ్ చేయాలి. when I click here save, it asks you to save in the particular location. ఓకే, ఇది మనని పర్టికులర్ లొకేషన్ లో సేవ్ చేసుకోమంటుంది. అప్పుడు మనం ఇక్కడ సేవ్ చేస్తాం, ఫిజికల్ మెమరీలో సేవ్ చేస్తాం, రైట్? లైక్ సి డ్రైవ్ ఆర్ డి డ్రైవ్ లో సేవ్ చేస్తాం ఇందులో. దిస్ ఇస్ కాల్డ్ as a physical memory. Here I will going to save the file. Okay, so virtual memory can be implemented via demand paging and demand segmentation. Okay, so based on the demand paging ఒక demand and demand segmentation, we are going to place this one. But మీకు ఈ కాన్సెప్ట్ లేదు, బట్ జస్ట్ ఇది ఒక కాన్సెప్ట్, ఇది ఒక లైన్ తెలుసుకుంటే సరిపోతుంది, రైట్? Based on the demand paging and based on the demand segmentation, the virtual memory can be implemented, right? Yeah. So we have two types of memories, logical memory and physical address space. Physical memory, right? So logical memory అంటే virtual memory అన్నాం. Physical address అంటే ఏంటంటే మనకు డేటా, వాట్ ఎవర్ ద డేటా we are storing permanently, that is called as a physical memory. So logical memory లో it is going to create all, for each and every one, it is going to create some space, address space. So on that space only we are storing these pages, or we are storing whatever the documents, whatever thing, right? So how it is going to create, now let me see. So logical address space, an address generated by the CPU is known as a logical address. It is also known as a virtual address. Okay, so an address is generated by the CPU is called as a logical address, and దీని ఏమంటాం, దాని virtual address కూడా అనొచ్చు, right? So logical address space can be defined as a size of the process. A logical address can be changed. Yeah, okay. A logical address space can be defined as the size of the process. So based on the process, it is going to be created. Like నేను ఒక ఇమేజ్, ఒక ఫోటో తీసాను అనుకుందాం ఎగ్జాంపుల్. ఆ ఫోటో యొక్క సైజ్ ఏంది, based on the requirement, based on the size of that particular image is going to be created. The space is going to be created, right? And the address also దాని యొక్క సైజ్ ప్రకారం సేవ్ చేసుకుంటుంది. ఓకే, అర్థమవుతుంది కదా? నెక్స్ట్ physical address space. So physical address space is also saved like this only. It is also going to save the data, but this is going to be saved data permanently. Okay, so an address seen by the memory unit, that is one loaded into the memory address registers in the memory, is commonly known as a physical address. Okay, a physical address is also known as a real address. Okay, real address, whatever they're using, we are using real address. The set of all physical address corresponding to these logical addresses is known as a physical address. Okay, so logical address nunchi, whatever the data we are getting from the logical address, the set of all logical addresses to the real addresses is called as a real address or physical address space. Okay, a physical address is computed by MMU, memory management unit. The runtime mapping for virtual to physical address is done by the hardware device memory management unit. Okay, the physical address always remains constant. Yes, yeah. So ఇక్కడ అర్థమవుతుంది ఏమన్నా, the runtime mapping for virtual physical address to physical address, from virtual to physical address ki ఏదైతే మ్యాపింగ్ చేస్తుందో, that is going to be done by the help of device called memory management device. ఈ మెమరీ మ్యాపింగ్ ఏదైతే ఉందో మెమరీ మేనేజ్మెంట్ యూనిట్ ద్వారా రన్ అవుతుంది, ప్రాసెస్ అవుతుంది డేటా అనేది, రైట్? సో the physical address always remains constant. Remains constant is nothing but whatever the data present here, this is always constant. Ante suppose example naadi 256 GB of memory, this one, this is 256 GB of memory. I am using 256 GB memory, so my memory is constant only. I can't increase that one, I can't decrease that one. So right, so it is whenever you see నాకు ఇక్కడ డేటా అంతా ఫుల్ అయిపోయింది, 140 GB ఫుల్ అయిపోయింది, ఓన్లీ 10 GB అవైలబుల్ నాకు ఉంది. But I want to, if I want to increase this one, I can't increase this one. Why? Because I have that much of space only, right? Here కూడా 97 GB లో only 10 GB is available, right? But whereas coming to physical logical memory, the logical memory will keep on changing. It is a dynamic process. Okay, the data is going to be changed, right? So this is about logical memory and physical memory. Do you have any doubts? Let me discuss rest of the topics in next class. You people have any doubts?
No, sir, not yet.
Okay, are you able to understand?
Yes, sir.
Fine, okay. Okay, file system. Tomorrow we are going to complete third and fourth unit, both actually. Chinna not third unit. Here we have some 2 to 3 algorithms like page replacement algorithm and someone. Okay, 1 2 algorithms unte avithe third unit అయిపోతది. The page segmentation and page replacement algorithms we have. After that we can get into fourth unit. Okay, and okay, yeah. Okay then, yeah, okay then, bye. Let me see you tomorrow.
Okay, sir. Thank you, sir.
Yeah, fine, thank you.
ఓకే సార్.
Fine, thank you.